Have you ever gazed up at the night sky, mesmerized by the countless tiny lights, and noticed how they seem to dance and flicker? It's a beautiful sight, but it begs the question, why do stars twinkle? You might be surprised to learn that the twinkling isn't actually coming from the stars themselves. Stars are not turning on and off like a faulty light bulb. In reality, they are shining with a constant, steady light. So, what's causing this magical shimmering effect we see from down here on Earth? The culprit is our very own atmosphere. Think of Earth's atmosphere as a massive, invisible ocean of air swirling above our heads. This ocean isn't calm, it's full of turbulence. There are pockets of air at different temperatures and densities, constantly moving around. Hot air rises, cool air sinks, and winds blow at various altitudes. This creates a chaotic, ever-changing medium that starlight has to travel through to reach our eyes. Now, imagine a single, straight beam of light traveling from a distant star. This journey covers trillions upon trillions of miles through the vacuum of space. For almost its entire trip, the light travels in a perfectly straight line, uninterrupted. But then, in the very last fraction of a second of its journey, it hits Earth's atmosphere suddenly. That straight path gets a bumpy ride. As the starlight passes through these different layers and pockets of air, it gets bent or refracted. It's the same principle you see when you look at a straw in a glass of water. The straw appears bent at the water's surface because light travels differently through water than it does through air. In the atmosphere, the light from a star is continuously bent back and forth, this way and that, by the turbulent air, because stars are so incredibly far away. They appear as tiny points of light in our sky. Even through powerful telescopes, they are what astronomers call a point source of light. This is a crucial part of why they twinkle. Since all the light is coming from a single point, this tiny beam is easily knocked around and distorted by the atmospheric turbulence. One moment, the light is bent directly into your eye, and the star appears bright. The next moment, it's bent slightly away, and the star appears dimmer. This rapid change in brightness and position is what our brains perceive as twinkling. It happens so fast, dozens of times per second, creating that beautiful, shimmering effect. So, if stars twinkle because of the atmosphere, why don't planets? You've probably noticed that planets like Jupiter or Venus shine with a steady, unwavering light. They don't seem to twinkle at all. The reason for this difference also comes down to distance. Planets in our solar system are much closer to us than stars are. While they still look like bright points of light to the naked eye, they are not point sources in the same way stars are. Through a telescope, you can see that planets are actually small, visible disks. Because they are closer, they appear larger in our sky. This means that the light we see from a planet isn't just one tiny beam. It's many beams of light coming from different points across the surface of that disk. As these multiple light beams travel through our atmosphere, they all get refracted and bent in different directions. However, the magic here is in the numbers. While some light beams from the planet might be bent away from your eye at any given moment, other beams are simultaneously being bent toward your eye. These effects average out. The dimming of one light path is canceled out by the brightening of another. The result is that the overall brightness of the planet appears constant and stable. The atmospheric turbulence is still there, but its effect is smoothed out because the light source is an extended disk, not a single point. It's like trying to disrupt a single thin thread versus trying to disrupt a thick rope. The rope is much more stable. Here's a fun fact. This twinkling effect, which is scientifically known as astronomical scintillation, is actually a big problem for astronomers. That same atmospheric turbulence that makes stars twinkle also blurs the images they see through ground-based telescopes. It is like trying to take a clear photo of something at the bottom of a swimming pool while the water is being stirred. This is one of the main reasons why space telescopes like the Hubble or the James Webb are so important. By being positioned above the atmosphere, they get a crystal clear, uninterrupted view of the universe, free from any twinkling or blurring. Stars seen from space don't twinkle at all. They shine with a pure, steady light. Some ground-based observatories have developed incredible technology to counteract this atmospheric distortion. They use something called adaptive optics. This system shoots a laser into the sky to create an artificial guide star. A computer then measures how the atmosphere is distorting the light from this laser in real time. It then uses tiny, deformable mirrors to make incredibly fast and precise adjustments, bending the incoming starlight back into a sharp focus. It's like giving the telescope a pair of corrective glasses for the atmosphere, allowing it to take images almost as sharp as those from space. So, the next time you're outside on a clear night, look up and find a twinkling star. You'll know that what you're seeing isn't a feature of the star itself, but a beautiful, shimmering illusion created by the turbulent ocean of air above you. And if you spot a bright, steady light that isn't twinkling, chances are you're looking at a planet, a celestial neighbor whose light is steady enough to withstand the atmospheric dance. It is a wonderful reminder that even something as simple as looking at the night sky connects us to the vastness of space and the complex physics that govern our universe. Thanks for watching. If you enjoyed learning about the science behind twinkling stars, don't forget to hit the like button and subscribe for more cosmic curiosities. Let us know in the comments what other space mysteries you'd like us to explore next.